very much. The second time today. So our colleague has told you about energy storage systems and everything about. I'm going to tell if something happens with it. So energy is something we noticed that you not can destroy. You cannot only transfer to something else. We're going to store more and more energy in the future because there's not always going to be sun, there's not always going to be wind, so we have to store it somewhere. So there are a few systems that now are used, but are going to become more and more. So what we have, energy storage systems, we have, may say, 5 big groups. This is electrochemical energy storage. This is everything about batteries. So what we talk most of now is lithium-ion batteries, but lithium-ion batteries, there's more than that, a lot of more than that. There's going to be technology. They always want to make the batteries better and better. So for the moment, correct me if I'm not wrong, lithium-ion batteries have a very big energy density. So you have different kind of lithium-ion batteries. So there are some safer and some not so safe. So, but the not so safe have not so much capacity. So it's sometimes between that you have to find a safe battery. So the second one is chemical energy storage. This is, I have told you in the other presentation about transferring hydrogen to electricity. So this is, we're going to see more and more systems like power to methane, power to methanol, power to ammonia. So even they're going to be transfer, let's say, hydrogen into ammonia, because ammonia, you can carry on ammonia on ships, because you can store it on a pressure of 50 bars, and you have NH3, so ammonia is in, hydrogen is in the ammonia. So you're going to see this more and more, because hydrogen is very, you can store it normally in 3 things, in liquefied, compressed, or also in metal hydride. So, but you can do it also in ammonia. So they're going to transfer power more and more in other systems, energy. So then you have thermal energy. This is like salt. Salt is a very good thing where you can store heat. So you get heat from the sun or something else, you store it in salt, you put it in caverns under the ground, and you can get it afterwards again. So this is a form of energy storage. Like you can do it also with a crane who put bricks to each other. So you have one brick, and the crane put another brick, and another brick, and another brick, and another brick. So this done when the energy or the electricity is cheap. The same crane can put this brick again off the tower when the electricity is not so cheap. So by turning the motor, instead of a motor, you make a generator. So you make energy. Do you understand? So a tower can be energy. So energy can be in everything. Then we have mechanical energy storage. This is something, I don't know, do you have power stations on water in Iceland? Yes. This is something that they do. They pump water above when the electricity is cheap, and when it is more expensive, then they let it down again. So you win by putting energy above and get it down again, and that makes the difference. And this is more and more that we're going to see. So there are a few things like above the second number 2, So the sun, you make by electrolyze hydrogen. So if you put power, electricity on hydrogen, you can split water. So water exists of hydrogen and oxygen. If you put electricity on it, you can do it by yourself. If you pick two pencils and you put a battery on and you put it in a box with a little bit salt, not too many because you can make a chloride. So, but if you put two pencils in it, because a pencil is this is carbon, it's a very good conductor, and you can make your own hydrogen. So going to be bubbles coming from an anode and a cathode. So very, very easy. So with this, you can get it in the chemistry lesson. But hydrogen is nothing so special. So, but I told you about the liter factory. So you have an electrolyze, and then you have within a car a fuel cell. This hydrogen is convert to electricity. Okay, electrochemical energy storage. We have a lot. Like for an example, Tesla power walls that we're going to see in homes. Yeah, this from not so many power to a lot of power. We see power packs and we see mega packs. We see that also not only Tesla but other ones. This are pictures that I have taken in an international how you call it, an exhibition, yeah, in Ghent. They are the new systems. So we're going to see this more and more. What I would like to know as firefighter, if such a system is in a home, I would like to know this. Because why? And the commanding officer goes to a fire, he puts the fire out, he thinks everything is out, but no. This lithium-ion battery on the walls burns again, starts burning again, because there is a reignition. So we have to be careful. I would like to have a system that we can directly mount the system out of the wall and put it outside. Problem outside. So these are things that we have to take in account. If you have a power system within the home, think about it. Think about also, I'm going to talk to you later about the gases. Parola already have said about the gases that can accumulate. Think about this, but I will come back to this. Also, the power system here, most on the right, is a high voltage. Battery energy storage in a home. High voltage in a home. Think about this. It's not only low voltage, it can be high voltage also. Other, from little to big. Energy storage system, in many cases, we find it in ship containers. I've seen a lot of incidents where a lot of people didn't know there were lithium-ion batteries in this energy container because the manufacturer, even the engineers, didn't know a lot of danger about this. I have seen also that they have been used extinguish measures that are good for electricity but not for lithium-ion battery fires, like a gas Novik 1230 don't gonna help with lithium-ion batteries. It's gonna help that your propagation maybe in your cabin is gonna be lower, but the cooling is needed on cell level. And as Parola said, what's the best, what's the cheapest? Water. The structure of an energy storage system is always the cell. This is the smallest part. This is also the part where you need cooling. You need cooling on cell level to have an extinguishment. If we can make that we have quick suppression on cell level, you have 10 seconds. When the thermal runaway starts, you have 10 seconds to act. If you act from outside, not going to help. It's like putting water on a roof. This is like just putting water on the roof where the fire is inside. This is not going to help. You need to have extinguishment on cell level. Then you can do something. A module have a module has several battery cells. So you have a cell, then you have a module. Further, you have racks, and if you have this all together, then you have a container. So it follows cell, module, rack, row. A few incidents. The first one I have investigated in Belgium. It was 2017 as one of the first energy storage systems that has gone into fire. I'm gonna try if I can put. This was a thing that the firefighters see if they arrive. So this is also learning for us. What is this black smoke? What is this white smoke? This white smoke, these are battery gases. We didn't know also from the first in the beginning, but those things are battery gases. If you see white smoke, this is a vapor cloud. This is a very toxic, highly explosive vapor cloud. The other things that you see, the black smoke with the flames, they are secondary fires. So if you see white smoke coming like this, it's like reading the fire. We need to build like a new thing that you can read the fire for structure fires. We need to have this also for batteries and other fires in the future. Sorry, I'm gonna come back. The fire brigade was notified. It was a container fire at the container park. According to call, it was a container containing waste. So this was a call that the firefighters had. However, this notification was not correct. There were 50 reports were received through 112 from persons with eye and respiratory irritation spread over a wide area. We must say also then it was a situation where there was almost no wind. There was cloudy, so the gases didn't have the chance to go up very quickly, so they could balance very, very near. So, but again, then try to know what has coming free from this fire. We know also another fire give also a lot of nasty gases. So we may not make it worse than it is. But I think if you have gases, you will have it in the beginning. If you have hydrogen fluoride, hydrogen cyanide, you're going to have it in the beginning, not after the fire is started, and that you have propagation. But in the beginning, you're going to have the most of the gases. The arrival at the vehicle, the first vehicle or the intervention team assume that they are dealing with an ordinary container of fire, as I have said. The door of the container was smashed open by an explosion. You can see the threshold that is in front of the container door. That's totally I have put in a circle around it. It was totally benched. So this explosion has happened before the fire department has arrived. When they are busy, there was a sudden jet flame coming out of the container. So this is important also. If you have this, don't go near. Try to do it from a distance. The temperature measured inside the container was at that moment 800 degrees of Celsius. What they have done a direct attack because this was the first time. What they have to do, they didn't know. What was a lithium-ion battery fire in 2017? What was it? They didn't know, so they think, I'm gonna do the best that I can. And they tried first with water. They have giving heavy reactions. Then they tried foam, again, heavy reactions. Then they tried powder, and didn't work. Then they say, what we have to do? And then they have put a monitor. You see it on the picture here. Put a monitor far behind from the container and put water in the container directly. The other thing that you see with the aerial ladder and with the other monitors, with the other fans, is to dilute the smoke. So the smoke is coming out of the fire to dilute it, because a lot of smoke you can dilute with water. But therefore, I would like to have in every parking lot sprinklers. But this is not possible. Sometimes not possible. But sprinklers is the best that we can have. It cooling down, it dilute the gases, it makes it more clear for us to go forward. So this was a reason for those fans. After 2 hours with full power, 2,000 liters per minute, they were stopped and to see what's happening. But again, after a few minutes, the battery boxes were back on 300 degrees Celsius and the flames were present again. So again, remember what I have said. This is like a roof where you put water on and it getting down like the drains. So it not can go at cell level. This is a problem. This is also why Perola has shown you about the Cobra system and the Muir system, that we need to go at cell level to extinguish or let it burn out. This is an overview of the intervention site. There was for Belgium, this was a huge thing. This site was an energy storage system. Let's say it was an examination of different systems, and even the container that the fire was in was not in use yet. Was not storing or doing his thing. There was energy in it. But it was not in use. Deployment of extinguished agent for a container 1 megawatt lithium-ion batteries. The monitor deployment 12 hours at a rate of 2,000 liters per minute is 1,400,000 liters of water for one container of 1 megawatt. So therefore, I say to the manufacturers, think. You can extinguish each fire with a glass of water if you are quick enough. And sometimes you cannot let it burn out, such a container, because it's near. If it's near to facilities where a lot of people are living, you cannot do this. Therefore, it will not always be possible to let it burn out. So for me, extinguishment at cell level, it may cost more, but it's needed. They have also used 400 kilos of this powder. What maybe has become also, if you put this is a natrium bicarbonate, this is salt. If you put salt into water, you make the conduction bigger. So maybe with putting this salt in it, they will have a more, let's say, aggressive firefighting, because salt gives, let's say, conduction is bigger and your battery will be quicker getting the power down. So salt is a conductor. This was another one in Arizona. At 5 p.m., one failed module at the energy storage system goes in thermal runaway. The local fire department arrives 7 minutes later and they see a smoke. They see a smoke. No one knows what it is, because no one has told them there was an energy storage system at their site. And this is already the case in a lot of cases. They don't know. The firefighters have to give, let's say, they have to give advice about something they don't know about. So the firefighters need to know what kind of system is in their area. This is very important, as the commander of the ship also said. So a lot of gases, what it is, no one knows. What is this gas? The fire department does not know, I have said it. The firefighters were equipped with minimal personal protection, so the officer on scene calls the local hazmat team. The hazmat team arrives at 6:18 p.m. and begins monitoring the escaping toxic gases and use a thermal image camera to measure the temperature inside the container. Firefighter and the hazmat team monitor the situation, and they say, okay, we're gonna go further. After all this time, they decide it was safe enough to open the door of the container. It was safe enough. The commanding officer have said it's safe enough. The photo was taken just before the door was opened. A few months later, there was a deflagration. So those explosions, this is more than an ordinary explosion. Those powers are huge. The resulting explosion blasts 3 firefighters 20 meters from the container, rips and destroys safety masks, and contaminates all person protective equipment with hydrogen cyanide, ACN. So everybody thought it was safe to open a door. This is something that I say, watch out guys. If you go into an apartment, to a building, you don't know there's an energy storage system aboard. For me, there should be warned that there's an energy system, storage system in each building, that you know about it, that the commanding officer can make the needed assessment to make that that his people go safe home again. A total of 8 first responders are hospitalized with burns, ACN contamination, and crushed body parts. After deflagration, there were no more flames inside the energy storage system. So what you see here, there's not a lot of damage. This is a gas explosion. This is nothing more. This is a gas explosion by accumulated explosive gases coming from the battery. Liverpool, United Kingdom. 20 megawatt. So when Drogenbos was a 2 megawatt. Energy site consisting 3 battery units and control unit that resemble shipping containers, again with shipping containers. Each unit contains about 45 modules of lithium cells and an automatic fire suppression system. It's a Dutch name, EOS is energy opslagsysteem, energy storage system is the same. It's Danish owned and remotely monitored from Denmark. This happens a lot. That it's not monitored by local, it can be monitored from a distance. Local resistance report an explosion. The first 2 units arrived at the scene and are confronted with a well-developed fire and see clear signs of damage on the container. So the explosion has already happened. Firefighters use ordinary attack lines and ground monitors to fight the fire. Again, you see the force, what's happened. The doors and both of the ends of the roofs are air coolers. They were blown away, one of the doors lying on the ground 6 meters from the burning container. So think about it. You can have explosion, you can have parts of the construction on your firefighters. Think about. Therefore, a lot of in the United States, they put fence around, and no one must enter the area before the right people, so an engineer from the installation comes to the scene. Also, there are sometimes connections to the containers with lines that they can put water in it from a distance. So I find it important. If you don't know what it is, stay out. See it like a chemical plant. If you don't know what you are dealing with, stay out. The response of the incident lasts a total of 59 hours. The automatic fire alarm system and the battery energy storage system appears to have gone off when the fire broke out, but did not alert the fire brigade. Another one, Beijing, China. This was one where we have lost colleagues. On 6th April, the Fire Command Center of Beijing received a call in a 25 megawatt DC solar storage charging integrated project. We're going to see this more and more, that you have solar panels, and not far from there, they're going to be energy storage systems. 74 fire trucks and 235 firefighters were sent to the scene. When the firefighters were dealing with the fire, a sudden explosion occurred in the power station without warning, leading to the death of 2 firefighters and injury of 1 firefighter. There are 2 firefighters too much. For me, this must happen never again. We know what can happen. We should try to warn us for this. Lesson learned. This is the video that Perola showed also. Do you remember the inside of the container of Arizona? There were no damage inside the container. So there was a gas explosion. For me, this is the same that you see here. Don't want to work. Strange. But you have seen it this morning. Ah, it works? Okay. So these are gases. What's so important? Thermal runaway from a lithium-ion battery. Perola have said the state of charge. This is very important. You see here this Tesla. This is a vehicle with full state of charge. You see a little bit smoke. And very quickly the flames. If you see this, all your problems are gone. The explosion, what you can have reignition, but you will not have. I'm going to show it again. You're not going to have an explosion. This is a very, very good video here. What you see, the density of the vapor cloud. You see here vapor clouds going very near to the ground and vapor clouds going up. I find it a very nice video to see for a firefight where you're going to ventilate. Where are you going to ventilate? Low or high? What are you going to do? You see both of them here. For me, this was a scooter with lower state of charge. Look to the gas coming out of it. Remember, Arizona. You see it? It's the same. And you see gases also directly go up. For me, there are 1 scooter. I think if you look to the table of Mendeleev, if you look to your full formula, I think that you will have gases that are hydrocarbons that are heavier than air, and other ones like hydrogen that will go up. Maybe also ones that will go up by the heat. I think because the gases are a mixture of everything. There are hydrocarbons, they are hydrogen, they are everything. So I think this is if you look to the table of Mendeleev, this is the thing that you see. I think. But for me also, this is also all new. As Perola said, we try to understand what's happening, to understand more, and to know how accident can happen. Battery is a closed box. Water cannot get in to cool. So again, this cell you cannot cool because you cannot get water into. This is a problem. You can put a lot of water. Remember, how many hours that they have put a monitor in it with 2,000 liters of water, and after so many time they put the monitor away, and it was again very quickly 300 degrees of.
We have a question from. No, he's gone.
He's gone. I hope not forever. Okay.
No, no, I'm still here. I just wanted to support you, Kurt, on the gases. That electrolyte produces propane and butane and the lighter gas, hydrogen. So I noticed you were talking about the Norwegian ferry Ytterøyningen earlier this evening. And the pictures from the police investigation show that the explosion come from below the engine room and the battery storage facility. So it comes from below the deck, just to support the heavier gases theory. Thank you.
Okay, thank you very much. So the theory is also supported by who was there was Oleg. Oleg. Okay, it's new for me. I have to learn Icelandic. So okay.
Well, I'm not from Icelandic. I'm from Norway.
Okay.
I work in the Norwegian Fire Department.
Okay.
With new energy support.
Okay, thank you. But thank you for the support. In fact, so the vapor cloud from a fire in a lithium-ion battery is often mistaken for smoke or steam. Like the thing that you see coming out of this scooter was not smoke or steam. In fact, the cloud is a super hot mix of toxic flammable gases, which usually include hydrogen cyanide, carbon monoxide, carbon dioxide, hydrogen fluoric acid, HF. This is very corrosive. Sulfur dioxide. This is also very nasty. Hydrogen chloride, nitrogen oxides, hydrogen carbons, including ethane, methane, and butane. So this is Professor Paul Christensen and Emma Sutcliffe have done a lot of investigation in this. I want to thank them for all this work that they have done. Then the knowledge. What power is inside, let's say, containers? If we see that we have here a step, maybe 500 watts, 750 watts, what power that one step has? This is one step, 500 watt, 750 watt. If we go further, the Drogenbos container was containing all of those Teslas. So you see the power that you're going to have within a step, that you're going to have within a Tesla, that you're going to have within this energy storage system. This is a lot of more things, a lot of more energy. Consider, this is something as commanding officer, as firefighter. The vapor cloud has not been yet ignited. Think about opening doors. Where is Murphy? I always try to think, where is Murphy? He has forgotten me. Somewhere he is. Where he is. Because he will come if you don't need him. High voltage in different areas of the energy storage system. Where we have high voltage, like in the cabins of the batteries, we have high voltage DC, but we have also in other parts high voltage when we have the connection to the grid. Also, there are things where you not can put water in. Corrosive and toxic substances. There's a need for adequate prevention measures, detection and suppression. There's a need for clear standardized identification. I'm working on this together with a professor from UL. where that we try to make guidelines, as I have said before, for every, is it now a boat, a ship, or anything else, we need to have good information. Also, standardized info about energy storage in line with ISO 17840. This is also very important that we have a contact person from the energy storage system, an engineer, who has to have available 24 on 24. If you haven't, this is like your chemical plant. You don't go inside till you have the guy who's gonna tell what's inside this thing. This is something in the United States that you already do. They have to have the engineer on site. And update training for responders. These are a few symbols that I have drawn. They are not ISO symbols, they are just proposals. Like, if you put this on a home, you know there's a vehicle powered by CNG in the garage. Fuel cell vehicle in the garage. Electric vehicle in the garage and solar panels in use. Then, energy storage system with lithium-ion batteries in the home. You know, there's an energy storage system in the home if you see this before you enter. There's hydrogen used in the home, or there's natural gas used in the home. This is an example of this is the people, I think you know the NFPA 855. So this is an NFPA 855 that they say there's a need for a clear sinus. So I was this week together with a battery guy from the New York Fire Department and also with Tesla that we talked about this, and we're going to try to go this way. Fire Department of New York said we like this way and we're going to try to do it. So what's in this information board that's going to be on the container? You know what kind of technology that you're dealing with. So in this case, it's an energy storage system with lithium-ion batteries. What's the problem? What's the dangers? You have the diamond from NFPA and you know it's high voltage. Then the area. Within this case, you have 3 areas. An energy storage system zone where your batteries are. There we can put water in. Because if you look by the extinguish info, you see again 1, 2, 3. 1, you can put water in. 2, this is the transformer zone from AC to DC, because batteries are DC, and they have to be converted to AC before they can be put on the grid. So there you cannot put water in. Okay? You have to do it with CO2 or something else. And then the switch zone, this is connecting to the grid. There you can put also no water on. Again, from the 3 areas, you have the dangers. You see it? The areas and the dangers beside it. Extinguish info. What kind of extinguish info that we have? There's an automatic aerosol extinguish system. As I have said, you can have an extinguish system, an aerosol, to extinguish the cables inside, but not for the high voltage batteries, not for the lithium-ion batteries. Therefore, you need to have water. And within the system, there's also, you see the firefighter, there's a water connection to the fire brigade. So the fire brigade can connect water to the container directly to put water in it. There's also a water spray extinguish installation. What kind of air crew is it? It's also important to know because the gases coming out of the air crew are so very nasty. And the info, there's no telephone number on it. They are QR codes. Because if you put the telephone number in it, maybe this guy on this number will leave the company, and this number is not. If you put the QR code on it, you can directly change it on the website. This is an example of a container that they have tried to make. What should be the best way to do it? So there's. I'm gonna maybe the presentations are available afterwards, but there's a fire department connection there of overpressure valves. So if the gas is accumulating before you have an explosion, the overpressure gases will gonna open, There's the right detection, because you need to have detection that right on the cell chemistry that has been used. There's a need for ventilation, a camera, 8x lighting, sufficient BMS, and further and further and further. Lessons learned, we need to have, do you remember this morning of this afternoon I have told about all those chapters? These chapters are the same, but a little bit changed. Like, these are approved also with Tesla. Tesla going to use this. Tesla going to make an example of an energy storage system using these chapters. So you see there, post-intervention operation decommission. I have seen incidents where the batteries were melted. Who's gonna remove all this? Batteries with stranded energy in it, with high voltage in it. So it's not only building, it's also figure out how you're gonna make that it can be safe, dismantled, decommission. How are we gonna do it? Other battery technology need to know. These are just small things. Not everything is on, but I believe, I don't know what you think. Solid state will be coming. I don't know an energy storage system, but you have the lithium-ion battery. Solid state is something that's for me is coming very quickly, also to ahead of us. What do you think? Yeah, you don't know?
Not sure.
And because there's a lot of battery technology, but I think solid state is gonna come. What is the difference? When with lithium-ion batteries, we have an electrolyte who is this is not solid. This is liquid, and it's based on ether. Ether, very flammable. With a solid electrolyte, you have no ether anymore. It's a solid one, but it may contain little metal. So we know, tabella of Mendeleev, we have lithium, natrium, kalium, rubidium, cesium, and francium. These are all alkali metals. So lithium and natrium, these are two ones that are already used in batteries. So we know again, if you put water on it, you're going to have reactions. But if you know this, you know it. And sometimes we have to have put water on it because we have to protect something. And again, lessons in life will be repeated until they are learned. If we don't learn from our mistakes, if we don't learn about incidents, they will happen again. So there happened incidents where we have lost 2 firefighters. So we must never say we didn't know it. We did know it. Never stop learning, because life never stops teaching. Thank you.
Kurt.
Yes. Oh.
Are we able to ask you
Yes.
questions?
Oh.
Thank you.
No.
Thank you. So you probably
course.
saw the previous lecture where Oscar was showing you the lithium battery storage
Yes.
in basically in a house where people lived.
Yes.
It's my best understanding after listening to Oscar that we don't have any regulations or rules regarding the storage of that. And on this table here, I'm sitting between 5 chiefs, 3 chiefs, 5 chiefs. They have no idea where there's a storage in the area that they live in. So I'm just giving the idea. If one battery was blasting up like that, how about the picture that Oscar was showing us?
Yeah.
Thank you.
This is this is needed. There's a need to inform. The firefighters need to know there's an energy storage system in this home. But there's another, I know in Australia, they are thinking to ban this. They don't want this anymore in home. There are other countries who say, well, we're gonna have them in homes, but they have to have a room that's ventilated there, that the gases can go away, and that you have alarms, that you have smoke alarms. So CO detectors, because if you have a fire, CO will be the best detector, early detector. Yeah. So yes, for me it's needed. Firefighters need to know this.
I have a little bit of information and also a little bit of question is, I wanted to add to what I said earlier, there is going to be, the energy companies are putting into their technical contracts, so when you have a house, you connect to the energy grid, if you're going to put up a producing unit, so like become a prosumer, where you produce energy, and perhaps if you store energy, you have to have it registered with the energy company. So that would be one way for the fire departments to know what's where, if there are any energy producing or energy storage in normal homes and maybe in smaller companies. So is that something you think it would be good?
I know that I have heard also in Belgium that they are busy with I don't know, even with the system that's from a distance, that's sending out the signal. There's an energy storage system in home that already send out the signal that they know. This is not only that they have to mention it verbally, that the system already sent a signal by computer or something else. But this is, by not saying something, you're not doing good. So the firefighters need to know everything so they can deal with it. There's always firefighters will solve the problem. They are the specialists, but if they don't know what the problem is, they cannot solve it.